So here we are, question 156, the first question on vectors. This is about a parallelogram in 3 dimensions. So to start with, I've just drawn here a picture of our parallelogram. It may look like this or it may not, it doesn't really matter. But the important thing about labeling the sides is the sides are labeled in either clockwise or anti-clockwise. So I've chosen to label them clockwise. It makes no difference to the outcome of the answer of the question. So the 2 sides that we've been given are SR and SQ. So these 2 sides here. And in a moment we'll find the lengths of those 2 sides. But before we do that, we'll look at the side QR. Now QR, to go from Q to R, is the same in vector terms as going from Q to S and then from S to R. So that's minus SQ plus SR, or SR minus SQ. So we can work out the vector QR by subtracting the 2 vectors that we've been given. And once we know the vector QR, we can find the length of QR using 3-dimensional Pythagoras. So the length of QR, or modulus of QR, is the square root of each of the 3 components of the vector squared and added together. So the length of QR is root 38. To find the length of SR and SQ, we use 3-dimensional Pythagoras on SR and SQ. So SR is root 14, 3 squared, 2 squared, and minus 1 squared added together. And SQ is root 18, 1 squared, minus 1 squared, and 4 squared, all added together. Now we've got the lengths of all of these 3 sides of this triangle. I can use the cosine rule. And that's the formula for the cosine rule for finding an angle. And when I put that into my calculator, I find that QRS is 42.5 degrees. So that shows you that my diagram is wrong, because my diagram might lead you to believe that QRS is obtuse, but in fact it's acute. So now we have to find the area of the parallelogram. I think the quickest way is to calculate the area of one of these triangles and then just multiply by 2. And if we have this angle here and we've got this side and this side, we can use the formula half AB sine C. So the area of the parallelogram is 2 times the area of the triangle. That's 2 times a half, the 2 sides multiplied together, multiplied by the sine of the angle between them, and that gives us 15.6 square units. So there we are.